This lesson is for Mrs. Cucci's College Now College Prep Math class. We are on lesson 4.2, linear functions and their graphs. Okay, so what we need to talk about first is the type of functions that we're going to be using. So a function such as f of x equals negative 300x plus 1800, whose graph is a straight line, is called linear. So you can remember that because it has the word line right in it. So we're going to talk about a few different ways in graphing these types of functions. The first way that we're going to discuss this is by using our intercept. So where it crosses through the x-axis and the y-axis. So another way that we can write the equation y equals negative 300x plus 1800 is by taking it and adjusting it so that the x and y are both on the same side. So by taking this and moving it over to where the y is, by adding it. So 300x plus y equals 1800. So all equations in the form ax plus by equals c are straight lines when they're graphed, as long as a and b are both not 0. Okay? Such equations are called linear equations in two variables. Okay, so we can quickly graph these functions by finding the x-intercept and the y-intercept and then graphing them on a coordinate plane. So in order to find the x-intercept, we can very easily find that by plugging in 0 for y and then solving for x, and vice versa. To find the y-intercept, we plug in 0 for x and we solve for y. So let's go ahead and do that for this first one. Okay, we're going to find the x-intercept and the y-intercept. So let's find the x-intercept to start. So to find the x-intercept again, we plug in 0 for y, and we solve for x. So 2 times 0, anything times 0 is 0. So it just goes away. And we get 3x equals 6. Divide by 3, and you get x equals 2. So that means you have an x-intercept at 2 right here. Okay. Find the y-intercept. So we plug in 0 for x this time and solve for y. So again, that just kind of goes away for us. And we get y equals 3. So on the y-axis at 3. And because you only need 2 points to graph a line, we're going to go ahead and we're going to connect these and extend. And then we're going to label. And it's as simple as that. Find the x-intercept, find the y-intercept, plot them, connect the points, and create your line. All right. So now let's talk about slope. The slope of a line through distinct points x sub 1, y sub 1, and x sub 2, y sub 2, meaning 2 different points, is change over y over change over x. Change in x. So a lot of times we call that rise over run. y2 minus y1 over x2 minus x1 is our formula. You'll also see it written as delta y over delta x. Delta, means change. Okay, delta means change. All right, so we're going to find the slope of each point, each pair of points here, using this equation here. y2 minus y1 over x2 minus x1. So first thing I'm going to do is I'm just going to real quick label them so that we can keep them straight. Okay, x1, y1, x2, y2. So y2, which is 4, minus y1, which is negative 1. So it's 4 minus a negative 1 over x2, negative 2, minus x1, minus a negative 3. And you guys know when you have minus a negative, those become positives. So 4 plus 1 gives me a 5, and negative 2 plus 3 gives me a positive 1. So my slope is 5. Okay, so y2 minus y1. All right, same thing over here. There's x1, y1, x2, y2. y2 minus y1. over x2 minus x1. Negative 2 minus 4 gives me a negative 6. 2 minus a negative becomes a positive. 2 plus 3 is 5. So my slope is negative 6/5. Okay, so that's how we find slope using the definition. All right, so we have a couple different possibilities for the slope of a line. And I'm sure you guys have seen these before. Okay. We're just going to sketch them out real quick. So if the line looks like this, the slope is positive. Okay, that's a positive slope. If the line looks like this, this is a negative slope. So basically you read from left to right, right? So we're going up with this one, so it's positive. We're going down with this one, so it's negative. If you have something like this, this is equal to 0. And then last but not least, if it's vertical, there's no slope. Okay? Okay, so let's talk about slope-intercept form of an equation of a line. The slope-intercept form of the equation of a non-vertical line with a slope of m and y-intercept of b is y equals mx plus b. So you can actually just bring this down. Right? The slope-intercept form of the equation of a line, of a non-vertical line, whose slope m and y-intercept b is y equals mx plus b. So basically what this means is m represents slope, b represents y-intercept. And this is how you guys are used to seeing equations of lines and graphing them as well. All right. So how do we graph using slope and y-intercept? So it's actually really simple. Your first job is to take your y-intercept and plot it on the y-axis. That point is always going to be 0b. So you're not going to go left or right at all. You're going to stay right on that y-axis. Number 2 is to obtain a second point using the slope. So we're going to use that rise over run. 3 is to use a ruler to connect the points, draw arrows on the end of both sides, and label. So let's try one, okay? We've got y equals 2/3 x plus 2. So again, it's y equals mx plus b. First thing I need to know is the y-intercept, and we know that that's b. So that's going to be 2. And then we want the slope. And we know slope is m. That's going to be 2/3. So we start by plotting the y-intercept. My y-intercept is 2. So that's going to be right here. I don't know why my screen is bouncing. I apologize. Okay, so from that y-intercept, we're going to use our slope to get another point. So again, it's rise over run. So we're rising 2 and we're running 3. Since they're both positive, we're going to go up and right. So over 2 and up 2 and over 3. Up 2 over 3. Up 2 over 3. Okay? And if you wanted to, you could also go down 2 and back 3, because we know a negative over a negative is equal to a positive. Down 2, back 3, that would work too, okay? So from here, we're going to connect our points. And we're going to label our equation, y equals 2/3 x plus 2. Okay. So we're going to graph by using slope and y-intercept of my function 2x plus 5y equals 0. So in order to graph this using slope and y-intercept, I first have to solve it so that I have a slope and y-intercept, which means I need to solve for y. So we want to get y by itself. Well, obviously this 2x is in the way, so let's take it and move it to the other side. Okay. We still have that 5 that needs to be moved, so we're going to divide both sides by 5. And we get y equals negative 2/5 x. So we need the y-intercept and the slope. So in looking at this, I don't seem to have that plus b that's on the end that I like. If there's nothing there, the y-intercept is 0. My slope is negative 2/5. So you start at the y-intercept, which is 0, and you rise over run. So we've got negative 2/5. So instead of rising, because it's negative, I'm going to fall. So down 2 and run 5. 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. Okay? You could also rise up 2 and then go backward 5. It doesn't matter if that negative is in the numerator or if it's in the denominator or if it's out in front. Either way is going to work, okay? So I can go up 2 and back 5 as well. Connect the points and label. Okay, so the next thing we're going to talk about is equation of horizontal and vertical lines. If a line is horizontal, its slope is 0. Okay, the slope would be 0. So therefore, its equation is going to be really simple. Okay? If the slope is 0, it becomes 0 times x, right? We know 0 times anything is going to give us 0. So it just becomes y equals b, right? So if it was y equals mx plus b and I'm telling you the slope is 0, 0 times anything is 0, that goes away, so it becomes y equals b. So how do we graph a horizontal line? Well, all we have is the y-intercept, right? So it just becomes a horizontal line. So at negative 4, here's negative 4, we get this horizontal line. An easy way to think about this is if it's y equals, it just passes through the y-axis. Doesn't ever touch the x, unless it's y equals 0. All right, so how would we graph x equals 2? Well, if y equals was horizontal, x equals is going to be vertical. We go over 2, and that becomes a vertical line. Again, only passing through the x this time. Okay, so last thing we're going to talk about is slope as a rate of change. Slope is defined as a ratio of change in y to a corresponding change in x. We can also interpret this as rate of change in applied form. So rate of change is another way of saying the slope. Okay. So slope is a rate of change. In 2007, the U.S. government faced the prospect of paying out more and more in Social Security, Medicare, and Medicaid benefits. The line graph below shows the cost of these entitlement programs in billions of dollars for 2007 with projections through the year 2016. Find the slope of the line segment representing Social Security, round to the nearest 1 decimal place. So 1 decimal place is the same thing as the tenth. Okay. Describe what the slope represents. All right, so we want to know the slope of the line segment that represents Social Security. So Social Security is your line that's in blue. So what we need to do is find the slope. Well, we're given 2 points, okay? We know how to find slope using points. y2 minus y1 over x2 minus x1. So let's say that this is x1, y1, this is x2, y2, and we're going to find the slope. 970 minus 582 over 2016 minus 2007. We get 388 over 9, which is about 43.1. So I have the slope, but what the heck does that mean? What does that slope represent? Okay. The slope indicates that from the time period from 2007 to 2016, the cost of Social Security is going to increase by approximately 43.1 billion per year. The rate of change is approximately 43.1 billion per year. So what that's telling us is every single year the cost of Social Security is going up 43.1 billion. It's a huge number. Okay. Last one. Modeling data with the slope-intercept form of the equation of the line. We're going to use the 2 points for single coverage in the problem prior to find a function in the form s of x equals mx plus b that models the average premium s of x for single coverage x years after 1999. Use the model to project the average premium for single coverage in 2012. Okay, so first thing we need to do is if we're looking for an equation, we need to find the slope for single coverage, okay? So again, it's that change in y over change in x. So we take our 2 points and we find the slope. 4704 minus 2196 over 9 minus 0, which is going to give us about 279. Okay. We also need to know the y-intercept. So where is it going through the y-axis? So if I look here, here's where I'm crossing through. And I know this is the point 0, 2,196. So I know that it's starting at 2,196. So we can write our equation. For single coverage, it's 279x plus 2,196. So if I want to know what it's going to cost in 2012, I can use this equation. I know x is years after 1999. Y is what you're going to pay, or in our case, s of x, right? S of x, same thing as y. So if I want to know 2012, I need to figure out what number corresponds. So how many years after 1999 is that? So here's 1999, that's 0. 2000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2012. So here's 10, 11, 12, 13. So x equals 13. 13 years past 1999 is going to give you 2012. So 13 years later, s of 13, we're going to substitute in that value. And after 13 years, what's my cost of single coverage? It's going to be about $5,823. All right, guys, please make sure that you do the practice document, and I will see you in next class's video.